hopefully you can see me and you can hear me. If you can't, please sing out in the chat window. But hopefully it's all going to work. I'll do some screen sharing, but first I'll just say welcome. It's the weekend for me. I assume it's the weekend for many others as well, unless you're joining us from the US, in which it's still Friday evening. Thank you for giving up your precious time, especially in these times where weekends are times that are probably being spent a lot with family and cherishing the things that are actually genuinely important to us. So what I'll do is I'll jump into sharing my screen and we'll get straight into it. As Dilly mentioned, please stay on mute the whole time. I'm probably going to try and fill up the whole hour with content, and then I'll happily stay online for any questions that you have afterwards, just to make sure we get as much content as we can to you, and hopefully you enjoy it. Okay, let me share a screen. Now, I'm hoping you can see my screen as well. Once again, sing out in the chat line if you can't. So
yes, we can see your screen.
Fantastic. So my name's Connor McDonald, and today we're going to talk about the pathway to 18C, 19C, and 20C, and even beyond a little bit. Now, the first thing you will have recognized is if you've been to any Oracle talks in the last few months, you'll see this interesting new template and color design we've got. I'm actually pretty happy with it. If you're that way inclined, I'm not that much into design, but if you are, you can go to design.oracle.com. The reality is, what it really means is for you is when you download the slides, they will be enormous. My apologies in advance, the new template creates enormous PowerPoint decks. So moving on, I'm from Perth. I live here in Perth in Western Australia. That's one of the reasons I like coming to India and places in Asia, because it's one of the closest places I can go to when I'm doing talks. Obviously, that's changed a little bit given current circumstances. It is funny how literally a month ago, when I gave this talk to another group of people in person, I put this map up because I wanted to show where Perth was compared to all the bushfires that were in Australia, because that was the big topic. That was the big topic a month ago, believe it or not, you know, bushfires ravaging Australia. Of course, times have changed dramatically. This is the map that everyone's looking at nowadays, and obviously it's quite disheartening, but I just wanted to put this up there mainly to say, we're doing this talk as a user group today. We are a technical community, and the word user group should be fairly obvious to you. You don't have a user group unless you have users. So I know a lot of us are probably pinned at home at the moment, but make sure we stay healthy, stay safe, and make sure we do the things that our own governments are telling us to do to make sure that this virus doesn't get any worse than it absolutely has to be. And I obviously have a selfish interest there. The faster this thing is resolved, the faster I can actually come and talk to you people in person around the world, which would be fantastic. But for today, it's just virtual. I love talking technology. This is how you get in touch with me. I have a blog, I have a YouTube channel, I have a Twitter account. For those of you that aren't on Twitter, one of the things that should be worthwhile noting is even if you're not sort of keen on Twitter, you're a bit cynical about it. I mean, after all, what can we achieve with just 280 characters? One of the things I think you should really be looking at doing is being involved on Twitter, even if you never send a single tweet, because most IT companies are based in the US. And if they're based in the US, then of course what happens is that's where most information comes from, because the US loves Twitter. So even if you never send a single tweet, I'd encourage you to get onto Twitter, follow people in the community. It's a great way to stay informed and educate yourself. This is what I do most today. I look after the asktom.oracle.com website, and given these new times of virtual everything, I'd encourage you to check out the asktom.oracle.com/office hours program. We realize there's heaps of people inside Oracle who you've never met and possibly will never meet because they don't have a job like mine where they go outward face into the community. We want to reveal those experts to you, and we do it via virtual meetings. We've had over 250 office hours sessions. They're much like this one. We just have a speaker on, they talk tech, we do Q&A, they're free, and we run about 3 or 4 every single week. So lots of good content. And if you can't make them, because similar to me, you're probably not in a US time zone friendly situation most of the time, we record every single one of them, and you can get them on YouTube afterwards. So asktom.oracle.com/office hours. Hopefully you get a lot of value out of them. So what do I mean by pathway? Really what we're meaning is these three significant releases, 18C, 19C, and 20C just around the corner. And because I'm talking about 20C features as well today, and 20C is officially just a preview release at this moment, I'll put up the standard Oracle Safe Harbor statement, but let's get straight into it. Now, before we begin, I've just set the scene there in terms of, yes, it's going to be about 18C, 19C, 20C, about features. I think we should probably clear the air and be a little bit honest here. A lot of you may not be on this call because of features. A lot of you are on these calls about these new releases coming out because of this. There's a huge time bomb ticking underneath our IT centers at the moment, and that is upgrading. A lot of us, and I'm a realist. I worked outside the Oracle Corporation for 20 plus years before joining Oracle. I've lived the real customer world. I know that getting upgrades done is hard. So the vast majority of us on the call are probably on 11.204 or those kind of releases, or maybe 12.1, 12.2. I'd be willing to bet that just a small number of us are on 18, even less perhaps on 19. So this is really about upgrade. People are thinking, oh my goodness, 11.2 is out of support. What am I going to do? I'm going to need to upgrade. What features are there? One thing I want to say is stop freaking out about upgrades. When we released our annual release cycle, 18, 19, 20, 21, etc., people got very, very scared because they were like, are you serious? Are you going to make us upgrade every single year? Are you insane? Do you know how hard it is to upgrade? We have to get budget, we have to get approval, we have to get regression testing done. It's just impossible. That was never our intention. And funny enough, the reason we have annual releases nowadays, and this sounds a bit rude coming from an Oracle person, but it's your fault. And when I say your, I mean the community, and I put myself in that community as well. We actually wanted to move to an annual release cycle to satisfy the requests and demands of our customers. And I think there are two kinds of customers that we needed to satisfy their needs. The first customer is what I call the WTH customer. You could probably come up with a slightly more rude version of that, but the what the hell customer. And they are the people that for them, upgrades is a big deal. It's a huge drama. And really, they're in that camp of, look, I'm on 11.2, leave me the hell alone. Just give me security patches because I don't want to get hacked. But other than that, don't make me upgrade. And that's my first kind of customer. And even though we have an annual release cycle, we are catered to that specific need. What we've chosen is particular annual releases that will be what we call long-term support. And you can see that on the picture there, 11.2 has had literally support for about a decade. I mean, that's the kind of support you get from Windows XP. You know, it's been around for a long, long, long time. 12.1, 12.2, and 18 do not have those long-term supports, but 19 does. 19 is effectively the next big jump for those people that don't want to upgrade very often. If you don't want to upgrade often, you go from 11 or whatever version you're on to 19 and you stay there. That's one of the things that's driven this cycle for us. We want to make sure that we look after that first type of customer, which is I don't want to upgrade often. And for them, we give them 19C. You can see it's going to have probably out 7 or 8 years of support as well. It's going to be corrections to 2023, extended support 2026, and if it's anything like 11, it'll probably go even longer than that. And the best thing is any supported version you're currently on can do one hop to 19C. There's no intermittent upgrades, there's no unload, reload. All those supported versions, you can literally jump straight to 19C with a single upgrade. And in particular, because Oracle now has so many of its own databases to upgrade, because we run a cloud business, we built this fantastic tool called Auto Upgrade. Mike Dietrich has a great blog post on it. You can see there, literally the old days of upgrading where you would look at the upgrade manual and it would say, here are 27 preliminary steps, then you upgrade, and here's 37 steps you have to run afterwards, has now gone. Now we have this auto upgrade tool, which does all that checking, all those testing and checking for you, and literally is a one-line command to have your upgrade running. So it's a pretty cool tool. Now that's the WTH customers, those people that don't want to upgrade very often. But that's not the only kind of customer. There's also what I call the OMG, the oh my goodness customers. They're the opposite. They have been desperate for us to release releases more frequently because they've been waiting for particular features. For them, having a long distance between upgrades is a big drama because they want to get features that give them a competitive edge over other customers. And so that's the other part of the annual release cycle. You can go to 18, you can go to 19, there'll be a 20, 21, 22, etc. For them, they no longer have to wait those big 3-4 year cycles that we used to have in Oracle days between major releases. Now they're getting releases in smaller batches more frequently. And if you're a customer on this call, you don't even have to make a decision one way or the other at the entire department level. You can do it literally on a database by database level. I worked with a customer recently which does exactly this. They had a data warehouse, and this was their upgrade cycle for their data warehouse. They were on 11.2. They went to 12.1 because their motivation was very simple: pattern matching. They were a company that did finances and fraud, and the pattern matching features in 12.1 were single enough justification to upgrade. Then they went to 12.102 because they had in memory, fantastic for data warehouses. Then they went to 12.2 because 12.2 had online table move, fantastic for data warehouses because you can compress data as it comes in without taking an interruption. Same customer, different database, went from 11.204 to 12.2 for attribute clustering because this was an OLTP database. Clustering attributes gave them some performance benefits, and that's it for them. They're going 11.204 to 12.2. They're touching nothing else until they go to 19C. So even in your one data center on a database by database basis, you can make that decision as to how you want to approach upgrades every single year to get those killer features, or as infrequently as possible because you don't like doing upgrades because of the risk and cost. The key thing is here is it's your choice. So just because we release databases every single year, don't feel that we're trying to put pressure on you to upgrade every single year. We built this mechanism because you demanded it of us, and we're hoping to serve both those customer types. So in this session, it's all about preparing what you're going to do when you get there to these 18s or 19s or 20s, depending on what your customer needs are. Now, there's a lot there, and you can actually get started right now. You can literally install nothing and get started on these modern releases. And this is the obligatory Oracle Cloud advertisement. You can literally jump onto our cloud and fire up any of these instances, even 20C, to actually get running and start running with them. Now, if you're a DBA on the call, you're probably one of those people that likes getting your hands a bit dirty and you're thinking, well, yeah, I'd actually want to install some stuff. But you don't want to spend hours and hours doing it, but you can choose to install just a little bit. We have some pre-built Oracle VMs that you can literally go on, download a zip file, fire up VirtualBox, and you're off and running. They've got the database pre-configured, they've got their patched up, they've got workshops in there as well. So if you haven't got much time, but you still want to play with the new releases, bang, you're straight in and going there using these releases. If you're a DBA like me that loves really getting into it, stuck into it, you can actually download the software as you normally would from OTN and actually install the whole thing from scratch. But even if you do that, it's still actually going to be easier than in the past. Once you get to Oracle 18, we don't actually ship you a zip file from which you install. We actually ship you a zip file, which is the Oracle home. You can see there, when you unzip the package you download nowadays, it's no longer a big sort of bundle that you have to store somewhere, and then you run the installer, which creates your Oracle home. The Oracle home is the software nowadays. You literally unzip it in place, run a configuration script, and you're good to go. So the moment you get to 18 onwards, even installation from scratch is actually easier. You can even do it even easier than that, because now finally, if you're on Linux, we can actually deploy the Oracle software with an RPM bundle. It used to be really frustrating to me as a Linux person that every piece of software on Linux would come as an RPM, except the Oracle database. You had to do something different. Now the Oracle database comes as an RPM as well. It's a one-liner install. And you can even install lots even as part of DevOps nowadays, because as opposed to having to totally configure a database from scratch, in 20C onwards, the Oracle home will be read-only. Those elements that would normally change in your Oracle home, your SP file, your password file, those kind of things have been moved out of the software distribution. The benefit of that is once you have a read-only Oracle home, it's trivial to copy. And if you can copy it and move it around trivially without having to worry about changing files, then of course you can run a database in Docker. it becomes very, very easy to attach a read-only volume to a Docker. And once again, you're very quickly firing up databases now in Docker. So for the rest of the hour, man, the time flies fast, doesn't it? For the rest of the hour, this is going to be like what I call a little tasting plate. I'm going to talk about as many features as I can without going into huge detail about each one of them, really just to inspire you to go look for yourselves. I want to cover as many as I can such that we get enough interest to show you what's coming in 18, 19, and 20. So number one, I say number one, even though we actually covered 5 features already. The unzip the Oracle home in place, faster installation, RPM install, Docker read-only. They're all features in their own right, but let's jump into number one. The first one is VMware. If you've ever run Oracle on VMware, as a DBA, generally it's been a pretty lonely place. And the reason it's been a lonely place is there's been some friction between Oracle and VMware. If you wanted to get support, you'd phone VMware, they'd say it's an Oracle issue, don't talk to us. If you wanted to get some Oracle help, you'd phone Oracle and they'd say, well, you're running on VM, it's not our problem. Thankfully, there's now a relationship between the two companies where even if you're running Oracle on VMware, you can phone Oracle and get database support, which is pretty cool. You can actually see there's a particular MetaLink note there, 249.212.1. That's the key line that we've added. Oracle customers with an active support country will receive assistance from Oracle when they're running on VMware environments. One of the cool things with that, of course, is you can now have Oracle running on VMware on your in your own data center, and you can literally lift and shift that image up to Oracle Cloud and run it there and still get the same levels of support. One thing I should clarify is we haven't made any changes to the way you license Oracle on VMware. So there's no changes there. It's still the same as arrangements as before. Number two, you can get an idea. We're going to be going through these as quickly as we can because, yeah, it's a tasting plate. Global temporary tables. Now, of course, global temporary tables aren't new. They came out in Oracle 8i, but something that has come out new in 18C onwards is private temporary tables. If you ever use SQL Server or other databases, one of the things they've historically done as databases is lock data as you read it. Now, if you've only ever used Oracle, that comes as just totally something foreign to you. But in other databases for a long time, and still some databases today, as you read data, it is locked from anyone else being able to modify it. And that can cause concurrency issues. So a common strategy to avoid read locking was to do this in other databases. Every time you ran a query and wanted to use that data, you would query it into a temporary structure. In a SQL Server, you prefix temporary structures with a hash, and that object, that high paid jobs, is like a dynamically created table on the fly. The data is copied into there, and then the read locks are released on the source employee table. This is still a common technique that people use in their databases that aren't Oracle because they want to avoid read locking. So if you're trying to migrate that to Oracle, well, that's pretty hard to do. And that's why we invented private temporary tables. This is what the syntax looks like. You can see at the top, I'm just doing create private temporary table, $, PTT, my temporary table, give it some column names, employee number, and then I can insert some data into it, and then I can query it. Now, at this point, you're thinking, well, that looks exactly the same as a normal table, the global temporary table, but looks the same as before. What's the difference? Well, the first difference is the moment you commit, literally the table ceases to exist. It's not like a global temporary table where the data stops existing. In this case, the whole thing evaporates on commit. You can override that, but by default, it literally is for the length of a transaction. It is a really, really temporary thing. And to show you how temporary it is, if I create a private temporary table, that second query is, let's go see if we can find it in user tables. It doesn't exist. Let's go see if we can find it in all objects. It doesn't exist. It's not even stored in the data dictionary. That's how temporary it is. It's actually stored just in your session. The definition is stored in your local PGA. That makes it incredibly fast to create because we don't have to do any database dictionary operations, and keeps it very, very temporary data, very quick to create, very quick to drop. It's also really, really private because the definition is only stored in your session. One session in the top there in blue can log on and create a temporary table with employee name and employee number. Another session in white at the bottom there can actually create the same temporary table with the same name, but with totally different column structure. Each session has its own structure, its own columns, unlike a normal or global temporary table. In those cases, the columns are shared. In this case, total freedom over how you define the same temporary table name in every single session. How do we know if it's not stored in the data dictionary? How do we know if a table is a private temporary one? Normally we would go look in the dictionary to see if a table is temporary or has any kind of particular attributes. The way we do it is it's all with the name. If you try create a private temporary table with the name myTT, you'll get invalid table name because there's actually an init.otter parameter, private temp table prefix, that actually nominates that every single private temporary table you have must start with that sequence of characters. You can change that, but by default, it is $PTT. Number 3, seeing as we're talking about temporary things, who remembers temporary undo? It actually came out, I think, back in, maybe it's even back as far as Oracle 9, maybe Oracle 11, I can't remember, but it's been around for a long, long time. Here is the theory behind temporary undo. You had a database that is read-only, and the most common example of that is an active data guard database. You've got a database, it's being kept in recovery mode in real time, it's open read-only. That's a fantastic resource for being able to do, for example, reporting off it. But as the name suggests, it's read-only, you can't actually do DML on it. Even an insert like that says, no, you can't do it. For Active Data Guard, what we're saying is you can only run queries. Now that's fine if we're running our own ad hoc queries, but unfortunately a lot of reporting tools, the Tableaus, the Cognoses, our own BI products, etc., they mainly do reporting, but they occasionally need to store some metadata. And that was a bit of a drama because you couldn't create metadata. The way we solved that for Active Data Guard in the past was he said, you can have this thing called temporary undo, which redirects your undo into the temporary table space. That eases the restrictions on a read-only database enough to let you create global temporary tables and then use global temporary tables to actually store that metadata. So you can see that I've created a global temporary table called report staging. I've inserted some data into it, and that would let me, for example, then use it in joins and things like that. The amount of people that actually took advantage of that was virtually nil. And the reason is third-party tools, your Tableaus, your Cognoses, etc., generally don't like using functionality which is vendor specific. So even though we gave this solution to take more advantage of Active Data Guard, none of the vendors really embraced it because they were pretty much, well, we don't want to be looking at global temporary tables and stuff like that. We just want to use normal tables. So it's a cool idea, but people didn't use it, therefore less benefit for your Active Data Guard. And in 19C, we've tried to address that. We have this thing called DML redirect. What happens now is we will actually take a read-only standby that is open for read-only, and we will let you do DML against it. A database like something like Tableau, Cognos, BI, etc., even a normal user, we can say, look, go ahead, connect to that standby database and run DML. Now you might be thinking, well, how's this going to be possible? How do we actually allow data changes against a read-only database? It's a contradiction in terms. What we do is we intercept the DML as it's applied to the standby. We redirect it to the primary. Now, if you're running Active Data Guard and read-only mode, anytime you make a change to the primary, it gets flushed to the redo logs. Those redo logs get sent over to the standby. So what we do is we simply intercept the DML, take a little bit longer to send that DML to the primary. We then let the reader logs flow back to the standby. When they arrive, we tell the person, yep, your DML is finished on the standby. They never knew it took the long road to the primary. So this is a way now of allowing small amounts of DML, that the kind of metadata operations that reporting tools want to do, to actually be allowed against the standby, that the reporting tool will never know that we actually intercepted it and sent it via the primary. Let's do a bonus data guard feature. I really like data guard, so let's do a bonus feature. We've all done this in the past, and that is we've got ourselves a beautiful data guard setup. We have a primary, it's beautifully in sync with a standby, and then we make some sort of mistake. We do a no log operation, or we forgot to do forced logging or something, and we make a mess of our standby. The most common example of this is people back up their archives and they delete them without actually checking that they actually made it across to the standby. Those kind of common mistakes that we make as DBAs. The net result is we've got a giant mess in our standby. Solving that is a pain. you normally have to go through and say, okay, what files do I need to recopy over? What archive logs do I need to sort out? It's a bit of a messy, complex way to make sure that we've actually got everything back in sync. Often we just give up and go, you know, screw it. Let's just copy the whole thing over again and start again. That's fine unless you have a 10 terabyte database, because that's the weekend gone. In 18C, we had this wonderful one-liner. You simply connect with RMAN to the primary, connect to the standby, and say, recover the database from service primary. That is not a full restore or anything like that. That is a command that tells RMAN to go look at both systems, look at the primary, look at the standby, work out what the problem is. Do I need to recopy a particular data file? Do I need to go get some particular archives back from backup locations and restore them, and then I reply them? It goes and works out the minimal amount of work to be done, and then literally brings your standby back into sync with a one-liner. This function is so cool, we actually backported it into 12.2. We had such demand for it. Let's go bonus data guard. If you've ever set up a data guard database, the first thing you need to do is run this on your primary. Alter database force logging, because what you want to do is make sure that no logging operations are achieved. But this is the net result. You suddenly have this giant flood of redo coming across the network from the primary to the standby, and you don't get an option. You have to do that, otherwise you run the risk of your standby getting out of date or out of sync traumatically. In 18C, we wanted to try and improve upon that, because at the moment you have two choices. You turn on force logging and you redo log everything. You turn off force logging and now you've got this mountain of maintenance to make sure that you never ever miss a no logging operation. You make sure you pick up all the right stuff. It's those two extremes you have to choose between. And especially for data warehouses, which do huge data operations, turning on force logging for them can be a bit of a nightmare. In 18C, we've introduced some compromises, some middle ground. This is the first one we offer. Alter database set standby no logging for data availability. Data availability means I want my standby to always be in sync and always have its data available in the event of a disaster. So in this case, I don't have to have force logging turn on the primary. But what will happen is when someone does a no logging operation on the primary and they finish it and they type commit, the commit is blocked. We race through and find out all the no logged blocks in the primary and we send them to the standby. At that point, the standby is now perfectly back in sync with your primary, and then we tell the primary, yep, that commit's good. So we actually block the commit until all those no logging operations have been safely put onto the primary. This is not via the reader logs. This is actually the blocks themselves are transferred over, and then bang, both primary and standby are in sync. The commit is then released. So we defer the commit to make sure we keep that guarantee of the standby being perfect. You can also be a bit more loose in that definition as well. You can do alter database set standby no logging for load performance. What this does is we allow a no logging operation on the primary. When you commit, we allow that commit to occur straight away. So no impact on the primary in terms of deferring the commit. At this point, obviously, the standby is now slightly out of alignment with your primary, but that's a decision you get to choose. In the background, we are now rapidly sending those no log blocks across the line like we were before to get the standby up to date as fast as possible. But there is that very small moment of time there where that is out of sync, but it's your choice. This is the key thing here. You get to choose the level of risk you want to undertake. So those two additions are pretty cool in my opinion. I will just depart from the talk just for 1 second here. If you don't currently have a standby for your production database, let me tell you why I think that's a really silly idea and why I think everyone should have a standby for every single production database and why it's free. Now that might seem weird, but I would be willing to bet every single person on this call who has a production database has a minimum of 2 servers. Everyone does, because you have a production server and you have a server for everything else. That's pretty much the bare minimum. I don't know of anyone that runs a single server in their entire organization. They always run 2. Most of us run a lot more than that, but at least 2. So you've already got 2 machines licensed for Oracle. That's given already. If you're running production on one, you can put a standby for that node on the other. It costs you nothing because that other node is already licensed for other things. And you think, well, why would I bother? The least important thing in my view of having a standby is actually its DR capacity. That's just an extra bonus. As a DBA, think of the things that you can do if you had a copy of production available to you at all times for basically no cost besides a little bit of disk. You can do application deployment testing on it because a standby can be opened, read, write, and flashed back to being in sync with the primary. You don't lose its ability to become a standby. You can do application deployments. You can use it for backups. You have to apply heavy resource backups on your primary. You can use it to gather stats on and then import those stats into production. Once again, less resources on your vital production resources. I could do a test of data patching. So many things become available to you when you have a second copy of your production data that also can serve as a DR machine and doesn't cost you any money. So I can't recommend enough having a standby for every single production node. Number 4, let's go a bit dark. Let's go a bit dark on the call. A nice form of murder. If you're a DBA, this will be the number 1 reason you want to upgrade to 18 or above. We've all been called out in the middle of the night when someone's running a query like this. They're inserting into my table select star from my huge, great, fat, enormous billion row table. And of course, when someone does this, this is what they can see on their screen. They're just getting the old hourglass and they go, oh, well, I'll just leave that and go home for the evening. And it's you at 2 in the morning that gets that phone call saying the server's in trouble, the archives are filling up, the CPU is getting smashed. So of course, maybe the issue was the query wasn't correctly done. Maybe they were missing this important predicate. They were only meant to load yesterday's data, not the entire thing. It doesn't really matter for us as DBAs. We still have to crawl out of bed at 2 in the morning. We crawl out of bed, log on remotely, or in fact, all of us are logging on remotely nowadays. We do alter system kill session, kill it off. We might do a kill -9, and then we go back to bed. The problem with that is you get very, very upset customers. They might be real customers, they might be your developers. It doesn't matter. They get very, very upset. And the reason for that is, yes, you've killed off that problem query, but you've also killed off the whole session. What if they had some other uncommitted transactions? What if they had some information in their SQL Plus session that was, they needed? There's so much stuff that could have been going on before they ran that bad query, and you just wiped it out. In 18C, this is what we've always been waiting for, I'd say almost since Oracle 7. The command we actually always wanted was this: alter system cancel SQL. That will kill the currently running SQL, but leave the session intact. Those 2 parameters are the SID and the serial number. You can also pass in a SQL ID. So finally, after all these years, we can actually just kill the running SQL and leave the user's session there. That's pretty cool. Number 5. Speaking of number 1 reasons, I've just spoken about number 1 reasons for DBAs, so let's throw a bit of love to the developers on the call. Here's one of the reasons I think you'll love moving to 19C. A really common requirement as a developer is taking information as it's stored in the database, which is typically in rows, obviously, and rendering it in some other format. You can see the logical groupings I've put on the slide there. We want to group people by 10, 20, 30 in terms of department. We often want to present that information across the screen. It's a very common requirement. How we used to do it was terrible. Back in Oracle 10, you could use the model clause, which, let's face it, if you understand that, you're doing much better than me. You could use sysconnect by in Oracle 9 with some analytics. You could use XML if you're that way inclined. And let's face it, if you're using XML, you probably should get out a bit more often. Or you could even write your own aggregate functions using our OCR aggregation replacement techniques. In 11G, finally, all that complexity disappeared. Thankfully, we had the list add function. And this is a really cool function because it literally reads like the requirement. I want to aggregate a list of employee names within the grouping of department. And how do I aggregate that list? I order it by employee number. So it actually reads like the function you're trying to achieve, except there was one problem that exists in listag. What if you have duplicates? And if I, for example, aggregate not the employee names, but the jobs in the Scott.emp table, you can see that Department 20 has several duplicate analysts. Department 30 has several duplicate salesmen. And if you wanted to get rid of them, it was actually quite hard. ListAg can't do it in all versions up to 18C. You have to write your own select distinct, use that in an inline view, perhaps a bit of self-joining. It gets fiddly. In 19C, really nice touch for developers, we simply added the distinct keyword, and the problem is solved, once again, with simple SQL. Since we're talking SQL, let's move on to number 6. In 20C, this is going to blow your mind, a thing called SQL macros. And it's a method of encapsulating SQL logic in the database inside the query engine, and we can do it at what we call scalar and table levels. Now, rather than talk about the theory of this, I think it's best to show you some examples. And it probably, the best way of thinking about it, if you've ever used SQL+, the concept of substitution variables, the variables that have an ampersand in front of them, think along those lines throughout these examples. Let's do an example of a scalar SQL macro. Let's say I want to write a function in my database, which is a numeric trim. So numbers get presented to me, a number called X comes in. If it's less than, say, a lower bound, then I return the lower bound. If it's greater than an upper bound, then I return just the upper bound. If it's between the lower and upper bounds, then I'll return the value of X. It's a way of trimming excessively high and excessively low numbers outside of a range. So there's my pseudocode. If it's less than lower, return lower, greater than upper, return upper, otherwise return the number itself. Now I can write that in pure SQL. We don't have a function inside Oracle that does it natively. So I've written a function called clip. I can't use the word trim because it's already a reserved function. But my function clip in pure SQL takes low, X, and high, and I simply do return the least and the greatest X, low, and high. So I use the existing functions least and greatest to trim off the high and the low values, and effectively there's my clip function built. This is what it looks like as a SQL macro. Now, the functionality looks similar, except a couple of key differences. Notice that it doesn't return a number, it returns a string. And the string is actually least, greatest, X, low as before, but it returns it as a string, not as actually a calculation. What a SQL macro is going to do is actually take that string and insert it directly into your SQL. So it's not actually a pure SQL function call. If I actually run this, having defined that as a SQL macro, select employee number salary, I'm going to clip the salary to be always between 1,000 and 2,000. The query engine dynamically replaces that clip function with the string from the clip SQL macro function I defined. So now it actually looks like this. It actually uses the native least and greatest functions. It's not calling a pure SQL function. We have dynamically replaced part of the SQL text. That's pretty cool, and also I think pretty scary, because now the SQL you write isn't necessarily the SQL that gets run. But why would we invent it? One of the reasons it's fantastic for cross-database migration. For example, in Postgres, if you're looking for something in a string, where it occurs in a string, we don't use in-string. In Postgres, we use strpos. So if I'm migrating some Postgres code that uses strpos over to Oracle, I don't have to go change the whole code base to change it to in-string. I can use a SQL macro. Whenever I see strpos, dynamically replace it with an in-string function. Believe it or not, that's the simplest version of SQL macros. We even have table level SQL macros. In this case, I have a function called budget. It takes in a department number. It can actually take in a set of department numbers, even though it looks like just a normal number there. The reason it can take in a set is because this is a SQL macro of type table. What it actually returns, once again, you can see the in line 3 and line 12, it's the extended quote syntax. So this is still returning just a string, not a query. And that string is the following SQL statement. And what's going to happen is any department number that comes in as a parameter, you can see appears in line 10. It gets treated as if it was a bind. How do we run it? I can now, for example, do a query like this. The East Coast is a set of department numbers, all the department numbers from my department table where the location equals Boston. That could be one department number, it could be 100. that becomes an input into my budget function. And that function will actually dynamically insert the SQL we saw in the previous slide there and nest that into this set of department numbers. So it becomes effectively, I'll go back once more, this query where department number in, on line 10, the list of department numbers from the location of Boston. So we're dynamically creating a query on the fly using a macro expression. Believe it or not, there are even polymorphic table macros. And we're not going to do the source code for that because it gets a bit hairy. But for example, you might write a function called NJ, which stands for natural join, where you can pass in any number of tables and we will dynamically rewrite it to become, say, a natural join. So SQL macros coming in 20C, I think are best described as very cool, very powerful, and they scare the daylights out of me at the moment because as a DBA, at the moment, I'm going to have to start looking at debugging code where the SQL changes on the fly as it's presented to the database. But the level of power there is very impressive. Number 7, 11:15, oh man. Let's go back to the number 1 reason for upgrading that DBAs chose. Let's go back to bad SQL for a second. Sometimes canceling the SQL won't help. And to help explain that, I tried to come up with a good metaphor. This is my girlfriend's cat, Tiger. Now, we got Tiger in December last year. And Tiger is actually not a nice cat. When she was at the rescue center, she looked very, very nice. That was back in December. Now, she's a very nice cat. The moment we got Tiger home, she was just the most feral, savage, scratches all the time, just a nasty cat. Christmas Day, December, Tiger walked out the door, never to return. And to be honest, we weren't that unhappy because it certainly wasn't the cat we were expecting. She was not a nice cat at all. So yes, there was a couple of tears shed, but in reality, no, we actually weren't that unhappy that she had disappeared. And much to our amazement, 3 months later, Tiger just walked straight back in the door. You know, just a lot thinner, just sort of going, where's dinner? And my first thought was, that's exactly the same as bad SQL. Bad SQL just keeps coming back. Even if I crawl out of bed at 2 o'clock in the morning and cancel a bad running SQL with my 18C features, you know what happens when someone sees their SQL has been canceled as a user? They go, my SQL get canceled. I'll press run again. And they just keep running the same bad SQL. Every time you halt someone's session, what tends to happen is they go, I'll run it again, I'll run it again. That's frustrating. In 19C, this is a fantastic facility for DBAs. You get to quarantine bad SQL. If SQL exceeds a number of resource consumption or an elapsed time, you can quarantine it such that it will not run again. If they try run it again, they get an error. You can do it manually. So for example, here's a SQL statement that simply loops through the Scott employee table millions and millions of times. It runs forever, and I simply go locate the SQL ID. I can literally create a quarantine for that SQL ID. Now, when someone tries to run it, they get an error. It doesn't run for a while and then gets canceled. They literally can't even start it. It says, sorry, you've used a quarantine plan. You're not allowed to run that query. So as DBAs manually, I can actually step in and stop SQLs from being run. But you can also do it automatically. This is existing. This is not brand new stuff. The cancel SQL directive has always been around in resource managers almost since I think way back in Oracle 9, which is if something runs for more than 10 seconds, I can switch a session into the cancel SQL group, which means it stops the query. But for example, here's a query that runs for 4 seconds. It's allowed to finish. If I make it run longer, it gets to 12 seconds. And at some point, Resource Manager came in and killed it off. So that's existing technology. The change we've done in 19 is when you employ this with Resource Manager, what will happen is it will also quarantine the plan. So yes, we killed it after 10 seconds, but now we've stopped it from being able to run again. That's pretty cool. How do we know if a SQL is being quarantined? We've actually added some columns to Beetle the SQL. It'll have you the quarantine ID and the number of executions we stopped. So as a DBA, you can go check in, yes, that's no longer a problem. I can de-quarantine it, etc. On that topic, One of the future things that we're aiming to do, and I stress this is future, this is not in any current version, including 20, is this. How cool does this sound? Let me walk through the workflow here. A SQL is running badly. It runs for more than, say, 30 seconds, and that's our limit. We cancel the SQL using Resource Manager. We then automatically quarantine it because we don't want people running that again. A background task will notice this. Fire off a tuning set with that SQL ID. Try come up with better ways of running that SQL. If we can find a better plan, or we think is a better plan, we will test run that better plan. If it's less than 30 seconds, less than our threshold, we will create a SQL plan management profile which will block the bad plan, enable the good plan, and then automatically de-quarantine it, and thus allow it to be resumed by the user. That is insanely cool. It does not exist yet, but you can see where we're trying to head. This is part of that autonomous style of database, a database that can find a problem, see if it can get a better solution, and automatically activate that better solution without you being called out at 3 in the morning. That's insanely cool. Number 8, who remembers multi-tenant? Now, that's a weird question because obviously multi-tenant isn't something that's gone. Multi-tenant is actually our strategic way forward. But I say remember it because I think it's ridiculously cool. I mean, the fact of having multiple pluggables under one set of, let's try that again. The concept of having multiple pluggables with independent namespaces under a single set of shared background processes, awesome for scaling databases. You get to do hot cloning across them. So really much one-line commands to actually copy, a prod to test or a prod to another copy of prod. No more data pump, no more RMAN duplicate, literally one line, create pluggable database from. You get to be able to do refreshes. You can take a read-only pluggable and actually have it dynamically refreshed from a source over and over again. You can actually create pluggable copies that refresh automatically across containers. So much goodness in multi-tenant, and yet not much usage. Some of the very big customers in Oracle use it, but the rest of us generally don't use it. And it doesn't take rocket science to know why a lot of people aren't taking advantage of all the fantastic things in multi-tenant, because we charge for it. It's a separately licensed option. That's obviously a pain point for many customers. Having said that, a couple of important things I wanted to stress on this call. Multi-tenant from 20C onwards is the only option. When you get to 20C, you must be on multi-tenant. There is no non-multi-tenant facility from 20C onwards. So if you're currently still running non-multi-tenant systems, and I don't mean licensed multi-tenant systems, I simply mean systems that have not moved their database to a single pluggable, which obviously doesn't cost you anything, you need to start looking at it. Only multi-tenant from 20C onwards. Now that seems like a bit of an imposition because you have to move, but to ease that, to throw a bit of a carrot in, to add some incentive. How is this? This is really good. From 19C onwards, you can have 3 pluggable databases with no multi-tenant license fee to pay. And that is across all editions, Express Edition, Standard Edition, Enterprise Edition. All these versions, you can have 3 pluggable databases now and not have to pay a cent extra for a multi-tenant license. So finally, you can do some cloning, you can do some hot cloning, you can do some refreshes, you can do some, sparse cloning for snapshot copies, all those cool things, and have 3 pluggable databases and not have to pay a license fee. If you want more than 3, yes, the license still applies, but now you can have up to 3 with no multi-tenant license. I can't stress enough, you want to start getting into moving your non-pluggable databases into being pluggable ones, even if that's just a single pluggable. And people have different opinions on this. My view is I think you should do it separate to upgrade. If I'm on 12.2, for example, or 12.1, I would move from 12.1 non-pluggable to having that database be a pluggable, and then I would look at upgrading to 19C. I wouldn't do it all in one hit. And the reason I say that is, one of the things that we support, obviously, is when you go from 12 to 18 or 12 to 19. If you leave compatible set to the lower number, when you upgrade, if you have problems, you can downgrade without having to restore. You just basically run a script and you can run it against the old version of the software. The one place we can't do that is if you go from non-pluggable to pluggable, non-pluggable 12 to pluggable 19. To downgrade if you have a problem, you need to restore from backup. We don't have that downgrade facility. So I like doing it in two parts. Obviously, if you have a small database and restoring from backup isn't a big deal, then you may as well do it in one big hit, because why not do less upgrades? But multi-tenant is finally something that we can all really benefit from, because we have up to 3 of them in 19C onwards. Number 9, back to our slow running SQL. This is one of the very super cool things in 19C. Maybe the SQL is fine, like maybe the SQL was good. Maybe they actually did rightly put that predicate at the bottom, which is get just the last hour of data, but maybe we needed an index. Maybe that was the problem. Maybe we forgot to put an index on load date. If you're a DBA and you've ever created an index, let's walk through quickly what you're meant to do before you create a single index ever on an Oracle database. You should go get all the SQL statements that might be impacted by it. Consider candidate indexes on those SQLs. You need to consolidate any overlaps. If I have a query that queries on A and B columns and a query that queries on A, I don't need 2 indexes. One query on A and B solves both those problems. So I need to consolidate them. Now, I don't create them there because that could impact other SQL statements, could make things worse. So I should create them as invisible and unusable. They don't really exist yet. And then do a virtual check of the explain plan to see if the optimizer would even look at them. If the optimizer is looking positive, then I would create the index really, actually consume the resource, but make it invisible so no one can see it. Because just because the optimizer will use it doesn't mean it's better. Sometimes indexes make things worse. So then I'd need to execute every SQL to make sure they actually genuinely got better. Decide if they actually do, if it's a useful index. If I had 10 SQLs and an index makes every single one of them worse, I'd stop there. If it makes 5 of them better and 5 of them worse, I would need to use SQL plan management to make sure the 5 that are going to get worse can't see the index. After all of that, now I can finally make the index visible. That's what you're meant to do as a DBA before you create a single index. Let's talk about what we really do as DBAs. The phone rings at 3 in the morning. Something's running really, really slow. We slap an index on so we can get back to sleep. I've called this index, let me get back to sleep, on the problem table with some columns, and then I'll fight all the fires that might happen in the morning. Let's be honest, that's what we do as DBAs. We never follow the best practice because that's hard. That's a lot of work. And so what if I said that the database could do that for you? In 19C, automatic indexes is exactly that. We actually follow that 10-step best practice. We actually capture candidate SQLs. We then identify by creating unusable invisible indexes and just check virtual explain plans. Then we actually build those indexes as invisible to actually test execute them. Then we decide which indexes are actually worth doing, and we use SPM to make sure that we actually going to have regressions. And we even do more than that, because we actually monitor all the indexes that we create manually or automatically to see if they actually are any of use, because over time we might want to drop them. And we do it every 15 minutes. As a DBA, we could never approach that kind of goal. It's stupidly cool, insanely cool. Now, don't get me wrong, there's a lot more for us to do on this topic. You know, we use indexes not just for performance. Sometimes we use them for foreign key locking. Sometimes we want to compress indexes. Sometimes we want to dynamically rebuild indexes or coalesce them. There's a lot more we intend to do, but even out of the box, 19C automatic indexes is insanely good. Okay, we're running out of time, so I'd cover just a couple of last few features for you. This is the big one, in my view. 18C Express Edition. It is a 100% free version of the Oracle database. Just like there was an 11G Express Edition, we finally got to having the next version, which is 18C Express Edition. And when I say free, this isn't like it's free for you to download and use on your laptop, or it's free for you to run a trial on like the trial software on OTN. This is free, no questions asked. This is the actual from the license agreement. You can build applications on it. You can prototype. You can run them in production on it. You can even distribute the database with your applications. You can use, if you're a training company, you can use this for all your training. You can copy the software and send it to other people. This is like literally, it's like literally genuine freeware. Now, these are the limits that come with it. 12 gig of user data, 2 gig of RAM, 2 CPU threads, 3 pluggable databases. You might be thinking, oh, what can I do with that? The Ask Tom database, which gets over 1 million hits a week, is a 5 gig database. You can achieve a lot with a small database. A lot of departmental apps will never hit those limits. And what's more, you can get even more than 12 gig, and I'll explain why in a second. But even more importantly, I've got a YouTube video. Please go to my YouTube channel. I've got a video showing what you can do in terms of performance. And even with that tiny amount of allocation of CPU, I've got a swing bench demo doing 200 transactions per second on XC. A lot of power in 2 CPU threads. Now you might be thinking, well, what features have you taken away? Back in 11G XC, there were a heap of features you didn't get. You didn't get bitmap indexes, no function-based indexes, no partitioning, no whatever. This is what you get in 18C XC. This will blow your mind. What is that a list of? Pretty much Enterprise Edition plus all of the normal extra cost options for nothing. 100% free. The only thing that's really not in there are things that make no sense to be in there. Rack, well, you don't want to probably run clustering on departmental level apps. The only thing we couldn't get in there is the diagnostic and tuning pack, like active session history. And our intention is to get it in there eventually. The problem was we simply couldn't cram it into the memory footprint. So we hope to get it in there, but other than that, it's all in there. Once again, as before, you get multi-tenant, 3 pluggables, and free XC. Think about what this can do for your departments. You could now have a multi-tenant database with 3 pluggables that cost you nothing, as in like no extra license on your development database. Take those pluggables, clone them out, give them to every single developer in your department. They're running 18C XC, which costs you nothing. They're allowed to run multi-tenant as well because it's free. So now you could take a clone of your central dev database, give it to every single developer running 18C XC on their own machine. It's like the ultimate DevOps solution, and it costs you not $1. Oh, it's 11:31. Let me finish off a few more slides. I did lie. There actually is something even bigger, believe it or not, than 18C XC, and that is this. If you want to run a database on the Oracle Cloud, on our absolute state-of-the-art hardware, I'm not talking about cheap stuff, I'm talking about the Exadata gear, you can do it for free as well. We have this thing called the Always Free Database. 2 databases up to 20 gigs, 2 VMs, 120 gig of extra storage, plus a load balancing virtual private network setup, all of that on Oracle Cloud, free. Not free for 30 days, not a free for trial, not a free where's your credit card, a free forever. As long as you're using it, we will keep it there. That is ridiculous. Already, due to this, these terrible situations floating around the globe at the moment, people have been using this facility to fire up solutions for their local communities. So if you want to build databases on the autonomous database running on Exadata, you can do it for nothing, and you can do it and you won't have to pay a cent forever. It's insane. If you want to get it all set up, my friend Dimitri wrote a great series of blog posts to walk through the whole thing. I know I'm a little bit over, so let's wrap it up. 18, 19C, 20C. Our aim here is that we have these annual releases to satisfy all the customer types. Those that don't want to upgrade very frequently, those that do want to upgrade very frequently, you get the choice. There's a huge amount in these products that we haven't even touched on today. You know, we could do this for hours and hours and hours and hours, but you just get bored with me. But the best thing is you can check it all out for free, either on your own machine using 18C XC or on our Oracle Cloud, or you can download the software. So much opportunity for you to become an expert in this, such that you're really fully equipped to take advantage of these features when the time comes that you actually do that upgrade. So we are done. Thank you very much for your time. Hope you enjoyed that, and I hope you enjoyed the session.
any changes in current pipeline function?
Not to my knowledge. Pipeline functions, I think, are pretty much the same.
Mhm.
One of the things that they do come into is when you get into the sort of SQL macro kind of area, the polymorphic table functions end up sort of perhaps almost being a superset of pipeline functions, because whereas before, if you had some complexity, you would put it in a pure SQL function and call it as a pipeline function to get access to it from SQL. It may well be the case nowadays that with a polymorphic table function, especially with macros, you may be able to do that in a polymorphic table function. But in terms of the base functionality, no, not much has changed to my knowledge.
Okay, we have another question from Raghav. Is automatic indexing available only for engineered system?
Yes, and let me explain why automatic indexing runs on engineered systems. And it's not because we're thinking, we want to, make it special for ourselves, whatever. Obviously, to detect if we are going to put indexes on, we follow that 10-step process, which means regularly querying the database for bad performing SQLs. That can be done very, very efficiently. However, we then need to build indexes. That obviously consumes a fair bit of resource. We then need to actually test execute bad running SQLs to make sure they get better. Now, if they're bad running SQLs, they obviously consume significant resource. So we have to build indexes, that burns resource. We have to test execute lots of SQLs, that burns resource. And we're doing this every 15 minutes. So the reason we chose engineered systems is most people license their normal machines. Like if people buy a server of their own, not an Exadata, if they buy their own hardware, they normally license just the cores they need. When they buy an engineered systems, what our experience is at Oracle is people much more buy effectively a large unit of work. They buy a quarter rack or a half rack or a full machine. So they're much more likely to have cores that are already licensed but spare capacity on engineered machines. So we have much more confidence in actually putting automatic indexing on those engineered machines because we're not going to harm their existing systems. If you've got a normal server which has your license for 8 cores and you're using all 8 cores already, which is a sensible thing to do, then we don't want to be the person that comes in and says, we're taking one of those cores away from you because we're going to do automatic indexing. So that's our logic there. Engineered systems generally have much more spare capacity because people buy the equipment in entirety as opposed to individual cores. Hope that makes sense.
Yeah. So is there any way to enable automatic indexing? Do we need to do something else to enable it?
If you're on an engineered system, no.
Okay, so do it comes with the extra licensing, or it comes with the
It'll be on your, my understanding is it'll be on your Exadata system.
Okay, and
that's the same reason we do it on cloud, because all our cloud machines are Exadata. So.
And one of our attendees, Ramesh, is asking, what will do while cancel SQL if the session rollback will happen? Means we will get the prompt.
Yes, that's correct. So if you're doing a large DML, like a delete or an insert, and that gets cancelled, the transaction will be rolled back.
Okay, that particular SQL will roll back, right?
That's correct.
Okay, so and one of the attendees, Jen, has asked, we have no CDB in our organization, and he or she is planning to go for the CDB. So is there any method we can easily deploy CDB container database in our organization from non-container database?
Yes. One of the nice things is it's actually I don't have them handy in my slides here, but there's I'll try find the information and send it on to you. But literally, it is effectively there is a series of scripts we run which takes a non-pluggable database and plugs it into a container database. You don't have to unload, reload. It literally just manipulates the dictionary to make the sufficient changes. So you'll have a standalone database and you will literally plug it into and it becomes a pluggable in your container database.
And one of our attendees, Sai Kiran, has asked, when we enable quarantine for a bad SQL, will it kill the session or particular SQL for that session?
No, only that SQL.
Okay.
So I could run 20 different SQLs, and if one of them is quarantined, the other 19 are allowed to run. It's only when I try run that 20th one, which has been quarantined, it'll simply say, nope, you can't do it.
Okay, we got it. So guys, if you have any question, can we upgrade? Oh, one of the attendees, Prabhas, has asked that can we upgrade directly to 12C PDB from 11.2003?
My understanding is you need to move to 12C and then plug it in.
Okay. Can we migrate rack? No, CDB.
Now the other option is, as someone has put on the chat line, you can move to 11.204 first if you feel that's lower risk. But 11.204 is, well, let me go a bit more broadly. No one should be running 11.203.
Yeah, definitely. So
can we upgrade multiple databases in a single server parallel? Yes, we can. I know you can do it manually. I will double check with Mike Dietrich, the PM, about doing that with auto upgrade, but I'm pretty sure I've actually been to a talk of Mike's where he actually did that on a VM. Like, he literally had several databases all upgrading at the same time, mainly so he could show different upgrade scenarios. So I'm pretty confident that even auto upgrade will actually do that. Okay,
so
plan changes.
Yep,
I'll answer that one. How to avoid plan changes after an upgrade? That is obviously a very, very common question we get asked, because a lot of people want to go to new releases to get new features, but they're going, what if it totally hoses my performance? And there's actually a very easy way of doing this. We have a thing called SQL Plan Management, which is one of those things where, and don't get me wrong, I'm not having a go at anyone on the call. I think we just came up with SQL Plan Management has a fairly complicated set of terminologies. We have this, baselines and evolution and acceptance and all these terms, but really SQL Plan Management is actually a fairly simple architecture. And one of the things it can do is capture plans for existing SQLs. So in terms of avoiding upgrade issues, what you do is let's say you're going from 11 to 19. On 11, you would turn on SQL Plan Capture using SQL Plan Management for a day, an hour, a week, etc. For such an amount of time that you're pretty confident you're going to capture all the critical SQLs. All those plans can be captured and exported into what we call a packed staging table. When you go to upgrade to 19, let's say, after you've upgraded, you import that staging table, and then you can actually then unload those plans. So what'll happen is every plan as it existed in 11 becomes the exact same plan in 19. It will literally run exactly the same as it did in 11. Now, what I then recommend to people is, over time, you then go check SQL Plan Management to see if 19 has come up with some better plans. Because one of the cool things of SQL Plan Management is it will lock you to the plans that you want, but it will still pick up better plans without allowing them to be used. And then over time, you can say, oh, 19 has some new optimizer features. It looks like this SQL will actually run better with this new plan, and incrementally you can activate those new plans. But you can insulate yourself against change by using SQL Plan Management. Why does the SQL ID sometimes change after an upgrade? I would like to see some evidence of that.
Okay, guys, if you have any questions left, then you can definitely reach to Kunal and contact him for any queries. So it's already 1 hour and 15 minutes. We have a session, so let's wrap it now. Thank you, Kunal, for the nice session, and we definitely have learned a lot from it.
No worries. Thank you very much for your time, guys, and hopefully the next time we talk, I hope it'll be in person. That would be fantastic.
Yeah, definitely. We will arrange it in-person visit, and we will do some offline sessions.
Hey, Romin, one attendee asked one question like, suppose I have one SQL ID with 3 plans and Oracle quarantined one plan. On subsequent run, does Oracle try to ignore that quarantined plan or just fail if Oracle try to use it? One attorney is asking this question. Kanor, could you please answer this question?
Okay, let's call these the last couple of questions. Okay, so the first one is, suppose I have one SQL ID with 3 plans and Oracle quarantine one plan. Oracle will optimize the SQL statement. If it comes up with the quarantine plan, it will simply block it. It doesn't say, oh, that one's quarantined, let's try use some of the others. However, you can use SQL plan management to do that, to actually make sure it doesn't use that, to make sure that one of the other plans is accepted. The other question was, how can we retrieve the quarantine SQL after it's been added into quarantine? There's some database views, can't remember them offhand, but even if you just query $SQL, where the SQL quarantine column is not null, you will get all the SQL statements that actually have been quarantined. So you can all tackle it that way as well. Okay, that's it. I'm answering no more questions. The rest you have to hit me on Twitter for.